Hey, hello everyone. Today we are going to talk about Unit 3, Lesson 5, and this lesson is on complex numbers. First, let's try to understand what are the complex numbers. Okay, we will take this problem, and in this problem, we have to find the square root of negative 48. So, can I write it down as square root of 48 times square root of negative 1? Okay, so now because we have square root of 48, in order to solve square root of 48 we have to make its prime factors. So I'm gonna divide it. We know that 6 times 8 is 48, and then you can make the prime factors of 6 as 2 and 3, and we know the prime factors of 8 are 2 times 2 times 2. Okay, so I'm gonna write this 48 as how many times we have to 1, 2, 3, and 4 times. So I'm gonna write down 2 times 2 times 2 times 2, and then we have 1 3. Okay, but remember one thing, when we are finding the value of square root of negative 1, because we actually don't know what its value is, so we assume it's letter I, and this is the origin of complex numbers. That's how we start the complex numbers. Okay, now if we have same pair of numbers, like you see 2 comes in pair, we have two pairs of 2, so they will come out of square root as single 2. So take one 2 out from here, take another 2 out from here, but 3 is not in pair, so it will stay inside the radical, and then I. Okay, so what is your answer to this problem? Your answer is 2 times 2, which is 4 root 3 I, and that is the answer of example 1. Okay, and now example 2 I can help you with also, which is very similar to example 1. So let me go and try example 3. Okay, so same way, just like we did in the previous question, we are gonna write 63 as square root of 63 times square root of negative 1. Okay, now let's make prime factors of 63, and the prime factors of 63 are we can say 9 and 7, right? And then 7 is already a prime number, and 9 will be 3 times 3. So basically we can write 63 as 3 times 3 times 7. And in the previous question I told you what is the square root of negative 1. Remember, square root of negative 1 is I, which is a complex number. Okay, so now these 3 comes in pairs, so they will come out as a single 3. 7 is alone, so it will stay inside, and I. So this is the answer to example 3. Now what you can do is you can pause the video here and try to do exercise question 1 and question number 2 and question number 3. Again, pause the video here and try doing these 3 questions. And after you finish it, we will go to example 2 now. And in example number 2, we have to simplify negative 3i times 4i. So whenever you have to multiply two complex numbers, so any number which is ending up with I is a complex number. So when you multiply them, multiply the number with number 3 times 4 and multiply I times I. Okay, and we know that negative 3 times 4 is negative 12, and when you multiply I times I is I square. And remember one thing, in complex number, if you have I square, its value is negative 1. Again, we are going to use it a lot. I square is always equal to negative 1. You can write it to your somewhere where you don't forget it. So negative 12 as it is, I'm going to replace I square with negative 1. So your answer to this question is 12. Okay. Now since you understood example 2, uh, I guess Uh, let's try another question, which is example number 4. And in example number 4, we have square root of negative 3. Can I rewrite square root of negative 3 as, I mean to say, square root of 3 times square root of negative 1? And I will rewrite 15 square root as square root of 15 times square root of negative 1. Okay. Now, uh, we have square root of 3 as it is, and we have square root of 15 as it is. And in the previous question, I told you that we can always write square root of negative 1 as I. So replace square root of negative 1 with I, and this one also with another I. So what you got here, remember one thing, if you have square root of a times square root of b, we can always write it as square root of a times b. So same way, we can write this as square root of 3 times 15, and we know that I times I is I square. Okay. Now, how do you solve this? Make the prime factors. So 15, prime factor of 15 are 3 times 5, and now we see that inside here we have 3 as a pair. It will come out as a single 3. Also, you will replace I square with negative 1. So your final answer is this negative sign and then 3, but 5 is single, so it will stay inside. So this is the answer to example 4. Alright, now since you know how to do example 4 and 2, you can go back to exercise, and please now pause this video here and try solving question number 4 yourself. Okay, so solve problem number 4 right now. Okay, after you complete question number 4, now we will go to the next page. Now we have to understand the operations with complex numbers. I mean, how do you add complex number? How do you subtract complex number? How do you multiply and divide complex numbers? Before even going into that, I'm going to tell you one thing, that when you're talking about two complex numbers, a complex number is always written as a plus bi. Okay, so every complex number is in this form, where a is the real part. I'm sorry, it is real, not real part. Okay, so a is the real part and b is the imaginary part. And if you want to add two complex numbers, just like we added the polynomials, you have to add the like terms. I mean to say, you have to add real part to real part and imaginary part to imaginary part. So what is the real part here? 6 and 4. So these two are real parts you will add, and then you will combine the imaginary part. Here the imaginary is I, and here it is negative 5i. Okay, so once you add them, your final answer will be, what is 6 plus 4 is 10, and what is I? If there is only I, is if we have 1 in the front. So what is 1 minus 5? It is negative 4i. So your answer is 10 minus 4i. That is how you will add two complex numbers. So again, how do you add the complex numbers? Just add real part to real part, and then you add imaginary part to imaginary part. That's how you will add them. Okay, let's take another example, and this time you have to subtract. Just like, remember when we subtracted the polynomials, we had to distribute the negative sign. So let's distribute the negative sign first. So I'm going to rewrite it as 8 plus 3i. 6 will become negative 6, and negative 2i will be positive 2i. Now what we are going to do, we are going to add the real part. So 8 and negative 6, they are the real part. So what is the sum of 8 plus negative 6? It's going to be 2. Okay, and now we will be adding imaginary part to imaginary part. So what is the answer of these two parts, 3i plus 2i is 5i. So 2 plus 5i is the answer to this question. Alright, so now we know how to add complex numbers. Now we also know how to subtract complex numbers. Now one last thing I'm going to do is how to multiply them, and then you will be practicing all the questions here of the exercise. Okay, so if you want to multiply two complex numbers, just like when we were multiplying the polynomials, we made a box of 2 by 2. Here also I'm gonna make a box of 2 by 2. And why 2 by 2? Because I have two terms here and I have two terms here. Okay, now let me write down 2 minus 5i here, and I'm gonna write down negative 4 plus 2i here. Okay, again just like we did other day, multiply 2 with negative 4, and 2 times 2i, it will be 4i. Negative 5 times negative 4 is 20, and then we have I with it. Okay, and now the last one is negative 5 times 2 is negative 10, and then we have I square, because there is one I here, one I here, so it's going to be I square. Now you know what we used to do. We know that the diagonal elements are like terms, so we can combine them, we can add all those values. So what is the first number we have here? Negative 8. Then second, what is 20 plus 4? 20 plus 4 is 24i, and we have negative 10i square. Now do you remember I told you that in complex number, if you get I square, you can replace it with negative 1. So I'm gonna replace this I square with negative 1. So let's do it one more time. We have negative 8 plus 24i and minus 10, and I square is negative 1. Okay, and we know that negative times negative will become positive, so it's gonna be negative 8 plus 24i plus 10. Now what you will do, just you will add the like terms. We know that negative 8 and 10, they are the real parts of the complex number, they are the like terms, so add them. It's gonna be 2, and then plus 24i is a single term, you can write it down as it is. So in this question, 2 plus 24i is the answer. Now you would have noticed that when you multiply, the process is pretty similar to when we multiplied the polynomial functions in the previous lesson. Okay, and I hope you understand this. And now please put your efforts, take your notebooks out, and try to work on all these problems that you have here. I have also attached an independent practice. If you have finished it early, then you can start your independent practice. Okay, have a good one, and I will see you tomorrow. Okay, thank you.